Alright, so today I'm going to be talking about the course of infection that a pathogen takes from all the way from the point of contact up until it exits the host. So the first step of a infection, I suppose, is that it must enter the host. So the pathogen will enter the host via open wounds, any of those entries of portals. So that could be your respiratory system, your GI tract, your urogenital system or tract, I'm sorry. This isn't universal for all microbes because obviously microbes have different pH requirements, different temperature requirements, use of enzymes, stuff like that. So this is all dependent, but it's important to know that the respiratory tract is the most common portal of entry for microbes. So when you inhale small droplets within the air or aerosols that are present in your environment, these are all good ways that pathogens can enter via your respiratory tract. That's why viruses like COVID, the flu, even tuberculosis, even though tuberculosis isn't even that common anymore, they're all good examples of viruses that can enter via your respiratory tract. So the next step is that the pathogen must adhere to the host tissues. Now, this could be done via pili, fimbriae, glycoproteins, adhesions, capsules. Now, this is obviously important for the pathogen. Otherwise, they would just get swept away from our mucus if we coughed, if we sneezed, if we expelled any fluids, anything like that. So obviously the pathogen must find a way to stick to our systems, to our tissues, I mean. So something that microbes will do is that they will create a biofilm. So biofilms are pretty important to know just in the world of microbiology and pathology and stuff like that. Biofilms are essentially a community of microbes, more so bacteria a lot of the time, that are surrounded by a slimy layer, also known as an extracellular polymeric substance. So EPS is the acronym. Essentially what this does is it makes them very adherent to whatever surface they're on. So it makes it very hard for them to get scraped away if you're brushing. So dental plaque is a good example of biofilms. It also makes them very resistant to antibiotics and to your immune system. Biofilms can be made up of sugars, proteins, DNAs, combination of all those. So they are very tedious to get rid of. That's why, like I said previously, dental plaque, you can't just brush them off unless it's soft plaque, but if it's harder plaque like tartar, you have to go to the dentist and you have to get it scraped off. So biofilms can also be found on medical equipment, so IVs, catheters, stuff like that. So it's very important if you're going to any healthcare environment that you are making sure you're cleaning those to the standard that they are supposed to be cleaned. So the next step is that they must invade your tissue. So this is step number 3. This is essentially when the pathogen is getting deeper or is infecting deeper into your tissues. It's becoming more systemic. This is usually done through the use of enzymes. So collagenase is an example of this. This is an enzyme that breaks down collagen, so it makes the skin and mucus in your body more penetrable for pathogens. Another one is hyaluronidase, which breaks down connective tissue. Sorry, I forgot. It breaks down connective tissue in your body. And again, that makes it more permeable for pathogens to enter in. Fourth step that we have is replication. Now, obviously, this is intuitive when you think about it. Everybody knows what replication is. This is how pathogens survive. This is how infections spread. Now, pathogens will, of course, steal the host's nutrients. So it could be sugar, amino acids, so proteins of such. More importantly, iron. Iron's a big nutritional necessity for a lot of pathogens. Now, the way they replicate is obviously, it differentiates based off the microbe. Bacteria, of course, go through binary fission. Viruses need to hijack other cells in order to replicate. They go through the lysogenic cycle, the lytic cycle, depending. All different. Parasites even will invade host cells and they will burst out. So it is all, of course, dependent on what kind of pathogen that you have. But when they do replicate, they are, of course, spreading deeper into your body. So it's becoming more systemic. They're damaging cells within your body. They are damaging your immune system. They are compromising your immune system. So the next time you get infected, your immune system is going to be obviously weaker than what it once was, or especially during an infection. I mean, I really just mean during an infection. So, and then last but not least, the pathogen is going to exit and eventually be transmitted onto another host. Now, the way that the microbe leaves is very dependent on what kind of microbe it is. So some microbes leave via your GI tract. So feces is an example. Your respiratory tract, so coughing, sneezing, stuff like that. Think of the flu, think of COVID. Those are all microbes that are expelled via your respiratory tract. Blood is a good example. So HIV, Zika, your urogenital tract. So a lot of STDs are expelled via that way. So semen is a good way that pathogens are excreted or transmitted. There's obviously so many STDs, chlamydia, HIV, HPV, gonorrhea. There's so many to name. And then microbes can also be transmitted via your skin, or they can leave via your skin, is what I mean. So scabies is a good example. Staph infections are a good example. So there are lots of ways that they can leave. Just think of those portals of entry, those portals of exit. And then I did draw out steps 2, 3, and 4. So you can see step 2 it's adhering to the surface. Step 3 is it invading, and then step 4 is it is replicating. So that's kind of what it looks like. Now I hope I made this easy to understand. I'm sorry if this was a longer video, but I hope you guys all learned something from it.